morning. I am Venkatrao, Professor of Mechanical Engineering, IARE, Hyderabad. Now, I will discuss about the topic game theory. So, in this, I want to explain about introduction, characteristics, problem solving methods, and some examples. The game theory is developed by von Neumann. He is also called as the father of game theory. Game theory deals with mathematical analysis of computative problems based on the minimax principle. In the minimax principle, each competitor will minimize his maximum loss and maximize his minimum gain. So everyone is interested in learning. Everyone is interested in games and learning how to win. Therefore, the game theory has received a considerable popular attention. However, so far, only simple games have been analyzed by this theory. This theory does not describe how a game should be played. It should describe the procedures and principles by which plays should be selected. So, it is a decision theory applicable to competitive situations. It is used in example in election, in wars, in advertising media, in business, etc. So in election, they have to select a right person. First of all, we have to study the persons who will get maximum votes in that area. Then we have to select that person. For that, this game theory is very much useful. In wars, how to destroy the important places of the enemies so that we can win the war. So for that purpose also, this game theory is very much useful. Then in advertising media. So in advertising media, how to attract more people, because different types of advertising medias are there. TVs, radios, newspapers, magazines, etc. But we have to consider the cost also. Based on the cost, we have to select the right advertising media. So for that also, this game theory is very much useful. In business also, how to improve the sales, or how to improve the profit. For that purpose also, this game theory is very much useful. Next, game. Game is defined an activity which is activity between two or more persons with a set of rules, at the end of which each person can get some gain or loss. Strategy. The decision rule by which a player determines his course of action is called as the strategy. Then, two-person zero-sum game. A game with two players where the gain of one person is equal to the loss of the other person is called as the two-person zero-sum game. In two-person zero-sum game, there will be two persons. The interests of the two persons are opposed, because if one person get profit, another person will get loss. That means the sum of their net gains are zero in a two-person zero-sum game. Two-person zero-sum games are also called as the rectangular games. That means the payoff matrix is in a rectangular form. Suppose there are n persons and sum of the net gains are zero, then that is called as the n-person zero-sum game. Next, payoff. It is the outcome of playing a game. A payoff matrix is a table showing the amounts received by the player is placed on the left side and the payment made by the person is placed on the top of the matrix. Now you can see here. So player A, that means player A will get the money and payment made by the person is player B. Here there are three options are there. Player A can select first row, second row or third row. Similarly, player B can select first column, second column, third column. Suppose if the player B selects first column, then he has to pay 3 rupees to the player A, or 2 rupees to the player A, or 6 rupees to the player A. So that means payment made by the player B is placed at the top. So the player A will receive. That means if player A selects the first row, he will get 3 rupees. second row 2 rupees, and third row 6 rupees, like that. Now, saddle point. It is a position of such an element in the payoff matrix which is minimum in its row and maximum in its column. Now, you can see, so in the first row, the row minimum is 3. In the second row, row minimum is 1. In the third row, row minimum is 1. In the first column, the column maximum is 6, and the second column maximum is 3. In the third column maximum is 6. In the maximum values, we have to select the minimum one. So here row maximum is 3 and column minimum is 3. These three are meeting at the point 3. That means the cell where the row and column meet is called as a saddle point. How to find a saddle point? Now you see how to find out the saddle. At the right of the each row, write the row minimum. At the right of the each row, write the row minimum. So in the first row, row minimum is 3. In the second row, row minimum is 1. In the third row, row minimum is 1. Next, in the first column maximum, that means the second step is at the bottom of the each column, write the column maximum and ring smallest of them. So now here, in the first column maximum is 6, second column maximum is 3, in the third column maximum is 6. So in this we have to ring the smallest element, that is 3. So row maximum is 3 here, max min value. So in the minimums we have to select the maximum. Here maximums we have to select the minimum. These two ring elements are intersecting at the point 3. So the cell where the these two elements are meeting is called as the cell where the corresponding row and column meet is a saddle point, and the element at that cell is called as the game value. Suppose if these two ringed elements are unequal, in that case saddle point is not available and the game value lies between these two elements. If there are more than one saddle point, then there will be more than one solution, each corresponding to each saddle point. Now we can find out the saddle point and game value for this problem is concerned. Now you see, corresponding to the first row, the row minimum is -3, and corresponding to the second row, the row minimum is 0. Corresponding to the third row, row minimum is -4. So in these -3, 0, -4, we have to select the maximum value. So 0 is the maximum value in this. Similarly, we have to find out the column maximum in each column. In the first column maximum is 5. In the second column maximum is 0. In the third column maximum is 6. So 5, 0, 6 are the maximums corresponding to the columns. Now in this we have to select the minimum value. So the minimum value is 0. In the column minimum is 0 and row maximum is 0. These two are intersecting at the point, in that means corresponding to the second row and second column. Now we can say 2, 2 is the saddle point. The 2, 2 indicates that second row and second column. And the game value, the cell where these two ringed elements are meeting is called as the game value. The game value is 0. That means the element at the intersection of this row and column will give us the game value. Determine the saddle point and game value for the following problem. Now, you see again in the similar way, we have to find out the saddle points and game value. So, for that, first find out the row minimum. So, in the row minimum is -2. That is there in the first column as well as in the third column. Then, second row, the row minimum is -5. In the third row, the row minimum is -8. So in these three minimum values, we have to select the maximum value, max-min value. So the -2 is the maximum. So it is ringed here. Again, in the column maximum, we have to select the minimum. So the maximum values are -2 in the first column, 20 in the second column, -2 in the third column. In these three, minimum values are, two minimum values are there. So -2 in the first column, -2 in the third column. So we have to select these two. This is also ringed and this is also ringed, because both the values we can select. That means in this problem there are two saddle points. So corresponding to the saddle point corresponding to the first row and third column is -2, and first row and first column is -2. So that we can get two saddle points. One is corresponding to 1 1, that is first row first column. Second one is first row third column, and the game value is the cell where the two ringed elements. So the row corresponding to the ringed element is this, the row column corresponding to the ringed element. These two are meeting at this point. So the cell where the two ringed elements are meeting is called as the saddle point. The element at that cell is called is the game value. Next, determine the saddle point, and that is over. Now the next one is arithmetic method. This arithmetic method is used to find out the optimum strategies and game value in 2x2 games. Procedure is, first subtract the two digits in column 1 and write against the column 2. Similarly, subtract the two digits in column 2 and write against the column 1. Similarly, for the rows also, subtract the two digits in row 1 and write against the row 2, and subtract the two digits in row 2 and write against the row 1. Now you see this problem. So this is the problem. Player A, the options are head, tail. Player B, head, tail. So we have to find out the oddments. Subtract the two digits in row 1. Row 1, 2 minus 1 is 3. So that should be written here. 2 minus of minus 1 is plus 3. Then here -1, 0. That is -1. Ignoring the sign, we can write this value, that is 1. Next, corresponding to the column 2 minus 1. 2 minus of minus 1 is 3 here, and -1, 0 is -1, so that you can write, ignoring the sign, 1 value. So these are called as the oddments. By using these oddments, we can find out the strategies. Strategy is equal to 1 by, that means this oddment by sum of the oddments. 1 by 1 plus 3. That is 1 by 4 is the strategy. So here also 3 by 4 is the strategy. Here again, here 1 by 4 and 3 by 4 are the strategies for the player A and B. Player A, the strategies are 1 by 4 and 3 by 4 for strategy. For player B, the strategies are 1 by 4 and 3 by 4. Like that, we can find out the strategies. Now you see here, the same thing I have written here. 2 minus 1 is 3, and -1, 0 is 1, and 2 minus 1 is equal to 3, -1, 0 is equal to -1, ignoring the sign, it is 1. Then strategies, 1 by 1 plus 3, that is 1 by 4, 3 by 1 plus 3, that is 3 by 4. So again here 1 by 4 and 3 by 4. So how to find out the game value? You can find out the game value either by using the A's oddments or B's oddments. You can use it. The game value using A's oddments. So the corresponding strategies are 1 by 4 and 3 by 4. 2 into 1 by 4 minus of -1 into plus 3 by 4. So that this value is -1 by 4. Or we want to use B's oddments. Suppose if you want to use B's oddments, 2 into 1 by 4 minus 1 into 3 by 4 is -1 by 4. If you take A's oddments or B's oddments, you will get the same value. Now find out the game value corresponding to this one. So here find out the oddments. For finding out the oddments, subtract the elements in the first row. That is -4 minus of 6. That is -10. minus 10, write against the second row. 2 minus of minus 3 is 5, write against the first row. For the columns minus 4, 2, minus 6. Minus 6 means 6 we have to write ignoring the sign. And corresponding to this, 6 minus of minus 3 is 9. So corresponding to the second column, we have to write in the first column, against the first column. So now the strategies are 5 by 10 plus 5, that is 15. 5 by 15, 10 by 15 are the strategies, and here 9 by 15 and 6 by 15 are the strategies. Now the game value is equal to, you can use these either the A's oddments or B's oddments. If you use A's oddments, minus 4 into 3 by 5 and 6 into 2 by 5. That means 9 by 15 means 3 by 5. 6 by 15 means 2 by 5. So minus 4 into 3 by 5 plus 6 into 2 by 5. So that is equal to 0. The game value is equal to 0. And the strategies are, for the player A, the strategies are 1 by 3 and 2 by 3, or 5 by 15 or 10 by 15. For the player B is concerned, the strategies are 9 by 15, 6 by 15, or this is 3 by 5, this is 2 by 5, like that. So these are the strategies available for the player A and B, and the game value is equal to 0. Determine the game value and strategies for a player A in the given problem. So already we found. Next, dominance rules. These dominance rules are used to reduce the game. Suppose 3 by 4 and 4 by 4 matrix is given. Then if it is possible, that can be converted into 2 by 2 games. Then we can find out the game value. Because arithmetic method is useful to find out the game value in 2 into 2 games only. Dominance rules for the rows. Dominance rules for rows is every value in the dominating row must be greater than or equal to the corresponding values in the inferior or deleting rows. Similarly, the dominance rules for the columns is every value in the dominating column must be less than or equal to the corresponding values in the dominated column. This dominance principle can also use it for the average values. If fewer strategies are not available, then we can also use the mixed strategies. Then, now you see the example. This is the matrix 0, minus 2, 7, 2, 5, 6, 3, minus 3, 8. From B's point of view, first and second columns dominating the third column. So here, for the third column, the values are 7, 6, 8. If B selects third column, he has to pay more amount to the player A. Because suppose if B selects the third column, player A selects the first row, B has to pay 7 rupees. If A selects second row, he has to pay 6 rupees. And if A selects third row, he has to pay 8 rupees. So B never selects this third column. That's why because in the first column 0, in the third column 7. So 0 is less than 7, 2 is less than 6, 3 is less than 8. Similarly, minus 2 is less than 7, 5 is less than 6, minus 3 is less than 8. That means the first column and second columns are dominating the third column, because these are the useful for the player B. His loss will be minimum. Suppose if B selects second column, A selects the first row, then B will get plus 2 rupees. Or if A selects the third column, in that case B will get 3. A will lose 3. That's why B never selects the third column. That's why the first and second columns are dominating. So the third column is dominated by the first and second. So delete the third column. From B's point of view, first two columns dominating the third column. So delete the third column and reduce the matrix. So this column is deleted, 7, 6, 8. Now you can see that this is the reduced matrix. The values are 0, -2, 2, 5, 3, -3. Now A's option. So the dominance rule for the player A is concerned, every value in the dominating row must be greater than or equal to the corresponding dominated values, dominated rows or columns. In the second row, 2 is greater than 0, 5 is greater than -2. That means the second row is dominating the first row. So delete the first row and reduce the matrix, because player will always tries to maximize his gain. So if he wants to maximize his gain, he has to select either first one or second one or third one. First row or second row or third row. So in this, he can select only the second row, because he will get either 2 rupees profit or 5 rupees profit. He never select the first row or third row, because if he selects the first row, he may get no loss, or he has to pay 2 rupees. If he selects third row, in that case, he may get +3 or -3. So if he selects the second row, he will get only positive things, that is 2 and 5. Now, so the second row is dominating the first row. So delete the first row and rewrite the remaining matrix. So now the matrix becomes 2, 5, 3, -3. So by using the dominance principle, the game is, this is the 3 by 3 matrix is reduced to 2 by 2 matrix. So this 2 by 2 matrix can be solved by using the arithmetic method. Now you see here, this is example for the mixed strategies. Pure strategies are not available in this matrix. Now we can use the average values. Now you see, in this problem, pure strategies are not available to reduce the matrix. Now take the average values. So the average of first and second row, 6 plus 0 by 2, that is 3. 6 plus 0 by 2 is equal to 3. 1 plus 9 by 2 is equal to 5. 3 plus 7 by 2 is equal to 5. So the values are 3, 5, 5. So the average of first and second row dominating the third row, because the player A gets more profit or more gain compared to the third row. So that indicates that the first average of first and second rows dominating the third row. So delete the third row and rewrite the remaining matrix. So the remaining matrix is 6, 1, 3, 0, 9, 7. Like that, we can reduce. If the pure strategies are not available, we can take the average values. Now solve the game whose payoff matrix to the player A is given. First we have to reduce the matrix. So first you see, the first column 1, 6, 0, second column 7, 2, 1, third column 8, 7, 4. Now from B's point of view, first column is dominating the third column, because 1 is less than 8, 6 is less than 7, 0 is less than 4. That means player B never selects this third column. So first column is dominating the third column. So delete the third column and rewrite the remaining matrix. So after deleting the third column, the matrix becomes 1, 7, 6, 2, 0, 1. Now A has to select first row or second row or third row. A will select the second row, because the second row is dominating the third row. Second row is dominating the third row, because 6 is greater than 0, 2 is greater than 1, so that he will get more gain if he selects the second row. So delete the third row and rewrite the remaining matrix. Now the matrix becomes 1, 7 and 6, 2. Now, so 1, 7, 6, 2. Now find out the odd means to finding out the game value. So 1, 7, subtract the 2 digits in row 1. 1, 7. 1 minus 7 is equal to minus 6. So write 6. 6 minus 2 is equal to 4. Then 6 minus 2 is equal to 4. You write against the first row. Similarly, you calculate the odd means for the columns. 1 minus 6 is minus 5. You write against the second column 5. 7 minus 2 is 5. So write against the first one. Now the strategies are 4 by 4 plus 6. That is 4 by 10. 6 by 4 plus 6. 6 by 10. Here also 5 by 5 plus 5. 5 by 10. 5 by 5 plus 5 is 10. Next. So game value to the player A. You can select the strategies of A or strategies of B. For the player A is concerned, 1 into 2 by 5 1 into 2 by 5 plus 6 into 3 by 5. So this you can write, this is 2 by 5. This is 3 by 5. So 1 into 2 by 5, 6 into 3 by 5. So that we are getting 25 by 5, that is equal to 4. So the game value to the player A is 4. So now you can see the matrix. So 1, 2, 3, 1, 2, 3. So actually it is a 3 by 3 matrix. So that we are having 2 for the strategies B here. This is also 3. So the player A is concerned, the strategies are 2 by 5, 3 by 5 and 0. Similarly for the player B is concerned, the strategies are 1 by 2, 1 by 2, 0. Because third row is never used. The possibility to use the first one 2 by 5, first row is 2 by 5, second row is 3 by 5, third row is 0. For the player B is concerned, possibility to use the first column is 1 by 2, second column is 1 by 2, third column is 0. Next. Method of matrices or determinants. So this method of matrices or determinants are used to solve the games, 3 by 3 games. Consider the following problem. So the procedure is subtract the each row from the above row and write the matrix. So here subtract the each row from the above row and write below the matrix. That means second row has to be subtracted from the first row. 7 minus 9 is minus 2. 1 minus 1 is 2. 7 minus 1 is 6. Similarly here, subtract the third row from the second row. 9 minus 5 is 4. Minus 1, 7. That is minus 8. 1 minus 6 is minus 5. So 9 minus 5 is 4. Minus 1, 7. Minus 8. 1 minus 6 is minus 5. Similarly, subtract the second column from the first column and third column from the second column and write on the right side of the matrix. So here 7 minus 1 is 6, 9 minus 1 is 10, 5 minus 7 is minus 2. 7 minus 1, 6, 9 minus of minus 1 is 10, 5 minus 7 is minus 2. Next, here subtract the third column from the second column. 1 minus 7 is minus 6, minus 1 minus of minus 1 is minus 2, 7 minus 6 is 1. So these are called the oddments. By using these oddments, we can find out the game value. Now you see the values are here. 6 minus 6, 10 minus 2, minus 2, 1, minus 2, 2, 2, 6, 4, minus 8, minus 5 are the values of the oddments. So the oddment A1. So the oddment A1 you can write like this. Oddment A1 is equal to, so if you want to find out the oddment of A1, so we have to delete this one, we have to consider the remaining two. That is 10 minus 2 minus 2, 1. So this is corresponding to the oddment of A1. That means you will get minus 10 minus of 4. That is equal to 6. Minus 10 minus 4. So that is 6. That means we have to take the modulus of that. That means positive value you will get. Similarly, A2 can be calculated like this. A2 is 6 minus 6 minus 2, 1. So you will get this value as 6 minus of 6 into 2, 12. That means again you are getting 6. Again next A3. A3 is concerned, we have to write like this. This is 6 minus 6, 10 minus 2. So here you will get 6 minus 2 is 12, 10 minus 6 is 60. So minus 60 means plus 60. This is minus 12. So that you are getting 48. So A1 plus A2 plus A3. A1 plus A2 plus A3 is equal to 60. Now you can see here. So A1 is equal to 6. A2 is equal to 6. A3 is equal to 48. A1 plus A2 plus A3 is 60. Similarly, we can find out the values here. So you can find out the arguments of B. B1 is equal to, now you can write B1. B1 is equal to 2, 6, minus 8, minus 5. So that is equal to minus 10, minus of 48 plus 48. So that this is 38. Then B2, you can find out B2 is equal to minus 2, 6 and 4 minus 5. So that this is plus 10 minus 24. So this is 14. Next B3. B3 is equal to minus 2, 2, 4 minus 8. 4 minus 8. So you are getting plus 16 minus 8. So that you are getting 8. So this is equal to 38 plus 14, 52 plus 8, 6. B1 plus B2 plus B3 plus B3 is equal to 60. This method of matrices or determinants is used when sigma AI is equal to sigma BI. That means A1 plus A2 plus A3 is equal to B1 plus B2 plus B3. Then only we can find out the game value or strategies corresponding to the matrix. Now these are the values. B1 is equal to 38, B2 is equal to 14, B3 is equal to 8. Now sum of the arguments A1 plus A2 plus A3 is equal to 60, B1 plus B2 plus B3 is equal to 60. Optimal strategies for the player A is concerned 6 by 60, 6 by 60 and 48 by 60. Optimal strategies for player B is 38 by 60, 14 by 60, 8 by 60. So game value is 7 into 6 by 60 plus 9 into 6 by 60 plus 5 into 48 by 60. So by multiplying and adding, you will get the value is 5.6. So like that, we can find out the game value in the case of by using the method of matrices or determinants. Now, sometimes the problem will be given. Based on the problem, we have to construct the matrix. Then we have to find out the solution. What is the problem? In a game of matching coins, player A wins 2 rupees if there are 2 heads. If 2 heads are there, then he will get 2 rupees. Wins nothing if there are 2 tails. If the 2 tails are there, then he wins nothing. And loses 1 rupee when there are 1 head and 1 tail. So this is a condition. Now determine the payoff matrix, best strategies for each player and value of the game to player A. Now how to construct the matrix? This is head and tail. So first in the first row you write H and T. In the first column you write H and T. Suppose if the player plays H, player B say H, then H and H. 2 heads are there. So player A wins 2 rupees. If player B says tail, player A says head, then head and tail. So head and tail means he will lose. Player A will lose 1 rupee. That means that indicates by -1. Similarly, player A says tail and player B says head. Again tail and head. in that case player A will lose. So minus 1. And two tails, player B says T and player A also T, in that case 0. This is the matrix, that means it is the payoff matrix. Now we have to find out the game value. First we have to find out the oddments. 2 minus 1 is 3, 1 minus 1 0 is 1, 2 minus 1 is 3, minus 1 0 is equal to 1. So that we are calculated the oddments. Next, strategies. Oddment by sum of the strategies, that is 4, 3 by 4. That is here 3 by 4. Here again 1 by 1 plus 3 is 1 by 4, 3 by 1 plus 3 is 3 by 4. So game value using A's oddments is 2 into 1 by 4 minus 1 into 3 by 4 is 1 by 4. So like that we can find out. If the statement is given, based on the statement we have to construct the payoff matrix, then we have to find out the game value. Then second problem. Two players A and play the following game. A has a bag containing 3 coins, one worth 1 unit, one 3 units and the rest worth 6 units. A takes 1 coin from the bag and before it is exposed, B guesses what it is. That means A takes 1 coin and asks what it is. Then B guesses what it is. If B guesses rightly, he takes the coin. If he is wrong, he gives to A coin of the same worth. He will give this value of the same worth. He will give a coin of the same worth which A has taken in the hand. Now, how to construct the matrix? So, first we write the values 1, 3, 6. First option 1, second option 3, third option 6. Similarly for the player also 1, 3, 6. So because 1 unit, 3 unit and 6 units are there. Player A takes coin of worth 1 unit. Then B guesses 1. In that case A has to give that 1 to the player B. So that means player A will lose. So against the player A, first row, first column, we have to write minus 1. Suppose if the player A keeping a 1 in the hand, player B says 3. In that case, player B has to give 1 rupee to the player A, 1 unit to the player A. Suppose player B says 6. In that case also, player B has to give 1 unit worth coin to the player A. Suppose player A takes 3 units worth coin. In that case, if player A says 1, then player B says 1, then player B has to give 3 units worth coin to the player A. Suppose B says 3. In that case, he will get 3 units. That means player A has to pay 3 units worth coin. Player B says 6. In that case, he has to give 3 rupees worth coin to the player A. That is corresponding to the second row. Like that, we can fill the second row. Third row is concerned. Suppose player A has taken the value of the coin 6. Then player B says 1. In that case, player B has to give 6 rupees to the player A. That 6 units worth coin to the player A. If player B says 3, in that case also he has to give 6 rupees worth coin to the player A. If B says 6, in that case he will get 6 from the player A. Like that we can construct the matrix. Now we have to find out the solution for this game. This game, again, by using the method of matrices, you can find out the game value. So here we have to find out the oddments. So minus 1, minus of 1, minus 1, minus of 1 is minus 2. 3 minus 3 is 6. 6 minus 6 is equal to 0. So subtract the second column from the first column and write on the right side of the matrix. Now subtract the third column from the second column, again write on the right side of the matrix. So 1 minus 1 is equal to 0. Minus 3 minus of 3 is minus 6. 6 minus of minus 6 is 12. Similarly for the columns are concerned, subtract the second row from the first row. So minus 1 of minus 3 minus 4. 1 minus of minus 3 is 4. 1 minus of 3 is minus 2. Then subtract the third row from the second row. 3 minus 6 is minus 3. Minus 3 minus of 6 is minus 9. 3 minus of 6 is 9. So first calculate the odd mates. Next find out the corresponding values of A1, A2, A3. Now find out A1, A2, A3. So A1 is now 6 minus 6, 0, 12. So here you can write here A1 is equal to 6 minus 6, 0, 12. So that you are getting this one is 72. So 12 into 6 is 72 minus of 0, 72. Similarly, A2. A2 is minus 2, 0, 0, 12. That means 24. You will get 24. A3, you will get, this is 6 minus 6. A3 is concerned. A3 is concerned. This is A3 is concerned minus 2, 0 and 6 minus 6. So that this is equal to 12 minus 0, that is 12. So the total A1 plus A2 plus A3 is 108. Similarly, we have to find out B1, B2, B3. So B1, how to find out B1? B1 can be calculated like this. 4 minus 2 minus 9, 9. So this is B1. 4 minus 2 minus 9, 9. That means this value is equal to 36 minus 18. So that you are getting 18. And B2 is 4 minus plus 4. This is minus 4 minus 3 minus 9. So that this is 36 plus 36 minus of 12. That is 36 plus 12. That is 48. 36 plus 12, 48. Then B3. B3 is minus 4, 4. B3 is minus 4, 4. B3. This is B3. B3 is minus 4 plus 4 minus 3 minus 10. B3. This is B2. B2 is concerned minus 4 minus 4. B2 is minus 4 minus 2 and then minus 3 plus 9. So that this is minus 36. Minus 36 minus of 6. That is 42. So that again the values you can see here. So B1 is 18, B2 is 42, B3 is 48. The sum is equal to 108 in both the cases. So you can use this method. So the values are A1 is 72, A2 24, A3 is 12 and sum is equal to 108. Here also B1 is 18, B2 is 42, B3 is 48 and sum is equal to 108. The strategies for the player A is concerned, oddment by sum of the oddments. 72 by 108, 24 by 108, 12 by 108. For player B is concerned, 18 by 108, 42 by 108 and 48 by 108. And the game value is 72 by 108. Next, the third problem. A and B play a game in which each has 3 coins worth 5 rupees, 10 rupees and 20 rupees. Each selects a coin without the knowledge of the other's choice. If sum of the coins is an odd amount, A wins B's coin. If sum of the coins is odd amount, A wins B's coin. If the sum is even, B wins A's coin. Find best strategies for each player and the value of the game. Now, you see, the coins are 5, 10, 20. Against the player B, we have written 5, 10, 20. Against the player A also 5, 10, 20. Suppose if the player A selects 5 rupees coin and B says 5. In that case, the sum is equal to 5 plus 5 is 10. If the sum is even, so A will lose. 5 plus 5 is 10. The sum is even, so A has to pay minus 5 rupees. Then, if B says 10, B selects 10, then A selects 5. The sum is equal to 10 plus 5 is 15, so that player A will get 10 rupees. Now, B selects 20, A selects 5. The sum is 25, so that B will give 20 rupees to player A. So, like that, we can consider the first row. Second row, if A selects 10, B selects 5, the sum is odd, so that A will get 5 rupees. If B selects 10, A selects 10, the sum is even, so B gets 10. Then B selects 20, then B will get 10 rupees because the sum is even. Next, A selects 20 rupees and B selects 5 rupees, then the sum is an odd amount, so that A will get 5 rupees. If B selects 10, the sum is even, so player B will get minus 20. B will get 20 rupees. If B selects 20 rupees, then A selects 20 rupees. The sum is an even amount, so that player B will get 20 rupees. Like that, we have to construct the payoff matrix. The left hand side player will receive the amounts. The top side player will pay the amount in the payoff matrix. Now, we have to find out the game value. Now, this can be solved by using the dominance rules. Now, you see, from A's point of view, second row is dominating the third row because 5 is equal to 5, minus 10 is greater than minus 20, minus 10 is greater than minus 20. From A's point of view, second row is dominating the third row, so delete the third row and write the remaining matrix. So now the matrix becomes minus 5, 10, 20, 5, minus 10, minus 10. Now, from B's point of view, the second column is dominating the third column. Why? The 10 is less than 20, minus 10 is equal to minus 10. So B never select the third column, so that the second column is dominating the third column. So delete the third column and write the matrix. Now the matrix becomes minus 5, 10, plus 5, minus 10. Now, player the matrix is given here. Now we have to find out the game value by using the arithmetic method. For that, we have to calculate the odd mints. Minus 5, 10 is 15. So we have to write against the second row. So here also 5 minus 10 is 15. Again write against the first row. Now minus 5 minus of 5, that is 10. Minus 10, we are ignoring the sign, we can write 10. 10 minus 10 is 20. So that you can write 20. 10 minus of minus 10, that is 20. So that you can write the strategies 20 by 30 and 10 by 30. Here 13 by 30, 15 by 30, 15 by 30 of COP. These are the strategies. So game value is minus 5 into 2 by 3 plus 10 into 1 by 3 is equal to 0. The strategies for the player A is 1 by 2, 1 by 2, 2 by 3, 1 by 3. Now you can see the third column is eliminated, third row is eliminated, so that you can write the player A is concerned 0 here, here also 0, because the given matrix is 3 by 3, so you can also write that one. So like that we can find out the game value and this one. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.